Okay, this is a short video to walk you through the solution of quiz number 2 in basic strength and materials. You were first supposed to determine the moment of inertia for this like cornhole board, which is basically the composite shape is basically a rectangle with a circular hole cut out of it. What I like to do in this case is develop a little table that looks something like this. So I have my two shapes, my rectangle, my circular hole. For the rectangle is 48 inches long this way and 24 inches long tall this way. So my moment of inertia about the x centroidal axis is 112 b, which would be 48, times h cubed, which would be 24 cubed. That comes out to 55,296. The area, 24 by 48, is 1,152 inches squared. Now there is no d distance here because the centroid of the rectangle lies in the same place that the centroidal x-axis for the whole shape lies. Both the rectangle as well as the composite shape both have an x-axis that lies right here. Because of that, there is no distance between the two axes. Okay, so AD squared is 0. So the way the parallel axis theorem works is you say IX, in this case IX for the centroid of the rectangle, plus AD squared is going to give me this. All right, for the circular hole, again, anytime you have a hole, you've got to treat the moment of inertia as a negative. You got to treat the area as a negative. So in this case, a circle, the moment of inertia about the centroidal axis of a circle is just pi radius to the 4th divided by 4. This is a 6-inch diameter hole, so the radius is 3 inches. So when I say pi r to the 4th divided by 4, it comes out to be about 63.6. Again, notice that it is given a negative because we are cutting this hole out of the bigger rectangle. The area, just pi r squared. Again, you treat the area as a negative. And again, the same way as we found with the rectangle, when I look at this circle, the centroid of the circle lies in the same location that the centroid for the whole composite shape lies. So the d distance is 0. There's no distance between the two axes. So again, IX plus AD squared gives me this. I then total these two values, okay? And the answer for the first part of the quiz was about 55,232 inches to the 4th. Okay? The second part was to determine moment of inertia about the centroidal y-axis for the shape, the composite shape. So again, I'll look over here at the right side, but you'll notice that the centroidal y-axis lies 24.4 inches in from the right side. So if I look again at the two shapes, rectangle and then the hole, the circular hole cut out of it, for my rectangle now, it's 112. The book will tell you 112 b cubed h, okay? So again, the base being cubed is 48 cubed. And this side over here is 24. I know I tell my group, I just say 112 bh cubed, but the base is always the side parallel to the to the axis you're looking at. So this side over here is going to be what what does not get cubed. This side down here is what gets cubed. All right. So anyway, when you do that, it comes up to 221,184. Area is still the same. Now again, the D distance here is 0.4. The reason being is when I'm looking at this rectangle that is 48 inches long this way, if I'm coming from this side, you're going to tell me I need the centroidal y-axis lies in 24 inches from the right side. Centroidal axis of the whole shape lies in 24.4 inches in from the right side. Therefore, there is a distance between those two axes of 0.4. Square that, multiply it by the area, and you get AD squared. You then take I of y plus AD squared gives me that value. Okay? Same sort of deal with the circular hole as the first time. It's just pi r to the fourth divided by 4. Area, pi r squared. Again, make sure those two things are negatives. And then for the hole, again, if you look at the hole here, its centroidal y-axis lies right here, but the whole shape's central y-axis lies right here. So you got to say, what's the distance between the two? All right, and in this case, it's just 24.4 minus 9. It's 15.4. Again, square D, multiply by area, notice the negative. So I've got this plus this negative plus this negative is equal to this negative. And then sum up my two values here to give me my moment of inertia and about the centroidal y-axis for the composite shape. It's like 214,593. Okay. The last, or the third and last problem on the quiz is sort of this shape that's sort of shaped like a home plate, and you're asked to find a moment of inertia about this x-axis that's sort of at the top edge. There's different ways you can do this. I chose to do it this way, where I'm going to break it down into 3 shapes. One shape being this rectangle, another shape being this triangle sort of on the left side, and third shape being the triangle on the right side. Okay, you can do this differently. This is not the only way you can do it, but anyway, when I look at the rectangle is 8 inches by 17 inches. Okay, so if I say I'm going to do the moment of inertia about this centroidal x-axis of just the rectangle, it's 112 times 17 would be the base, times 8.5 inches and cubed would be the height. All right, and that comes up to about 870. Area is 144.5. Again, now you got to say, what's the distance between the centroidal axis of just the rectangle and the axis that I want this moment of inertia taken about. So in this case, it's half of 8.5, it's 4.25. Again, like we saw the last time on the first couple problems, I take area, I multiply it by d, the distance squared, and then I take ix plus 80 squared to give me this value. Okay? Now, each of these two triangles has a centroidal axis as well. In fact, you could treat it as one triangle if you really wanted to, but I chose to do them separately. A triangle, the moment of inertia for a triangular shape about its centroidal axis is 136 BH cubed. Okay? So for me, my base again, is 8.5. And again, on this one, my height is 8.5. So 136 BH cubed. Okay, that's going to give me about 145 for each one of these, for both of these triangles. Okay, area, just 1/2 base times height, and gives me an area of about 36.13 for each of these. Now again, the D distance is from the centroidal axis of these triangles to the axis that I want this about. Okay? So in this case, if you say, hey, where does this centroid lie? If you're just looking at sort of from the edge of the triangle, you'd say it's 1/3 of, in this case, you might want to call this the height, 1/3 of 8.5. But my axis is all the way up here, so I have to say 1/3 of the height plus 8.5 inches. And so that's going to come up to 11.33 repeating for each of these. When I do that, I come up with 4639 and some change. You could say 4640 if you carried out the threes far enough. But anyway, just like I did before, I'm going to take IX plus 80 squared, and that's going to give me these values here. And then I'm going to take these three values, I'm going to add them up, and it comes out to approximately 13,049 inches to the fourth. If you did, round